Hello, everyone. Thank you for coming down to hear me talk today about formal verification and finding hope in the impossible. I think it's a good time for that story. Everyone needs a little more hope these days. I just want to see, out of the audience we have here, raise your hand if you've used formal verification, like if you actually used formal verification in your software. Certora people, you're cheating. Okay. A couple of people. So some of you are here to learn brand new, and that's good, because I'm gonna speak briefly about formal verification at a high level and what it does, and some of the criticisms in the past and where I think it's going in the future. But largely, the technical details of formal verification are not going to be discussed. I'm happy to discuss those out of band. So come and find me. We've got a bunch of people here in Certora who will happily help you learn how to use this stuff. So my name is Jonan. I go by the Jonan Show on the internet all over the place. This is a picture of me setting up our hacker house the other day here in Denver. We have a hacker house going today where you can come by and build a badge, and we have an escape room. We have a big party tonight. There's all kinds of stuff going on. If you scan this QR code, it'll drop you into our little Telegram group, and then you can go and learn more about it. But among the things that we have at the hacker house is a little PCB that you can assemble if building a multicast multimodal mesh device to achieve proximity-based key exchange is a thing that sounds interesting to you, or hardware hacking generally, or just that kind of club that is into that sort of thing, the Order of the Builders. Come and talk to me, and I'll give you one of these afterwards. I'd love to hear from you. We'll hang out. So I work at this company called Certora. Certora had some big news this week. We just open sourced our prover. This is open source formal verification now. We are, I think, before I worked there, I also thought kind of at the forefront of what's happening in formal verification. We've been around a long time. We've been working on this for 6 years. And in that time, spent rather a lot of money building what I think and we think is the best prover out there. And of course, we would like you to try it. So if you get a chance, go by Certora.com and check it out. It's a pretty cool product. It's very easy to use. And that is a thing that we've been wanting in formal verification for a long time. So let's talk about that. Formal verification, just for those who are brand new here, we're talking about mathematical proofs of program behavior. Not necessarily that you are proving that your program is correct, right? Because you're talking about the behaviors, and the correct behavior of a program is always up to the interpretation of the author, right? But what formal verification can give you the ability to do is to state an invariant about a system. You could say something like, hey, we're building a bank. The collective balance of all the people in the bank should never go below zero, because then we're not a bank anymore, right? You could state that about your system. And now what Certora's prover can do, and other existing provers, similar technologies can do, is they can go through those rules, test your program with every possible input that could come up, every situation that could come up, and they can say, yes, this rule holds, or if it doesn't, they will provide you with a counterexample of how to do that. This is what formal verification is. You work through these and you use different types of logical reasoning to write these rules and write invariants and modify your program in a way that makes it easy for us or another outfit who has written similar software to go in and break it down to a bytecode level and analyze it there for these formal verification methods. Long term, this means some pretty important things, but we'll get to that in a minute when we get to talking about the future of this technology. So, this is on Hacker News from a few years ago. I talked to people a lot who are saying like, yeah, people used to be critical of formal verification in the 70s and 80s, and nowadays mostly people have adopted this thing, right? I think we live in a little bit of a microcosm that many of the people here in the audience probably work in the DeFi space. We certainly all work in Web3 or are familiar since we're in this building. And that makes us a pretty small community, actually. I think in 2023, they said 28,000 Web3 developers worldwide in the Electro Capital report, something like this. As compared to about 0.5% of the 9 billion people on the planet, we're only 28,000 of those. So we have this perception maybe that formal verification is a thing, but very largely outside of the Web3 space, people say, oh, I think I did a half of a semester on formal verification when I was in college. And then they told me that it couldn't be done, that it couldn't be useful, right? Which is exactly what happened in this case. Why don't people use formal methods? The really simple answer to this question is it isn't useful, basically. Most applications are being specified by people who don't truly understand what they're trying to specify, he goes on to say, which is a really important distinction here that is important to understand about formal verification generally, that we are not proving that the entire program can work. For a very simple program, obviously you can do that, but the systems that we build are far too complex to prove every facet of them, and it's not necessary that we do that to improve the quality of our software. I think it's very important that we move generally in the practice of writing software towards declarative programming. And I'm going to come back to that a little bit and what that means to me. So this is just a quote from Dijkstra, who had a lot to say about formal verification. He had some criticisms, as many did, but I think largely in support overall of the idea of formal methods. But one of my favorite quotes is that simplicity is a great virtue, but complexity sells better. Which I bring up only to say that this problem is not going away. We can expect software complexity generally, the complexity of the systems that we build, to explode over the next decade. I would say in the next 2 years, right? You may be working on an application that's broken up into 300 microservices on your laptop by several different AIs who decided that was a great idea, right? These systems are going to escalate in complexity as we start to adopt artificial intelligence into our workflows. Already today, they are so complex that we could certainly measure them entirely for formal verification, but it may not in the end be worth the investment of effort because there are a certain number of states that we want to avoid in these systems. In the DeFi space, that one where they get to trade a token for all 9 billion tokens, that's the one we want to avoid, right? So this brings back to that topic of declarative versus imperative programming. And I have a quote on here from XKCD, "Sudo make me a sandwich," where guy's making a joke about getting his friend to make him a sandwich in a comic. But the idea is that we very largely program imperatively these days. We have like a lot of computer science students. I don't know, some people come from different backgrounds. We have a lot of CS people out here. You ever hear the CS example where your professor's like, "Hey, teach me how to make a sandwich"? Yeah? You're familiar with this? He's standing up there with a jar of peanut butter, a jar of jelly. They do this often. I'm surprised if no one here has ever done this exercise, but basically, the class is tasked with coming up with a sequential set of tasks that will result in a sandwich, right? So it's like, pick up the knife, put it in the peanut butter, right? But we didn't remove the peanut butter lid, so then he's stabbing the peanut butter, right? All these like comical errors that he makes as just this basic automaton, which is exactly what we do in programming all day, actually. I argue with a robot and get frustrated because it's too stupid to understand human reasoning because it is not a human and does not reason, right? What I'm doing is I'm telling it explicitly to pick up the knife, to open the lid, to put the knife in the peanut butter, to pull some peanut butter out, to put it over here. It's a very involved process, right? What if instead I stated a certain number of things about the world that I wanted to be true, and I let the software determine how to make that true? So I declare about the world that a sandwich is peanut butter and jelly between 2 pieces of bread, and it looks like most other sandwiches. And I set an AI about the task of making that real, right? In the world of software now, when we bridge this idea over, we're talking about the idea that in the future, AI is probably going to be writing most of the software. I know this isn't true for all of us yet, but I think for many software engineers in the last year, we've taken to using AI in our jobs full time, right? And you think about what that's going to mean for us going forward from the perspective of formal verification. And it's not great for the world generally, this AI thing, I think. And we can talk about that another time. But one of the things that it does a lot and is a real problem is that it hallucinates things, right? It will just make things up. And it does this based on, you know, all of the LLM magic, but effectively it is intentionally randomizing itself at some level, right? That an LLM is designed to intentionally randomize itself, seeking better input. It's part of this like self-training, right? And when we are building programs, that's a real big problem because I'm not looking for your artistic interpretation of my pop-up, right? I'm not looking for what you think might be a good UX robot because it's going to be horrible. I want a very specific thing, and I want to define it very specifically for it, and I want you to give it to me. And this is my biggest frustration with AI is that they will remember a thing and be convinced that you wanted the blue background, and they just keep putting it back, right? But if you define instead about the state of the world, look, the page always has a red background. Now, your robot can go back and make as many changes as it wants. It can hallucinate and think that you meant green. It can modify your website in all sorts of other ways. But at the end of the day, if that test doesn't pass, that the background is red, then you're not done with your task. You keep going, AI, right? So this hallucination vaccination step, I think, is one of the primary values in the future of formal verification. I don't want to discount too much the value that it can add to your lives immediately today. The AI component is certainly going to be relevant, but right now, there are people using formal verification to make sure that their smart contracts function the way that they They expect them to. And there are a lot of auditors out there who are using these tools. There are a lot of auditors who work at this company called Certora, where I work, who are using these tools. This technology is available today. Many of the criticisms of it over time have been based on the fact that it was implausible to formally verify an entire program. And we agree. That may be actually true. For most complex systems, that's probably true. It may not be worth your time to analyze every dark corner and find every bug that could exist, right? But certainly the ones that are going to drain your entire pool and bankrupt your company instantly because you missed a thing with a human being looking at a contract. And I know a lot of these security research, a lot of them, they're brilliant, they're really good, but human beings are fundamentally flawed at this thing, at just looking at a complex problem and saying, yep, we're good. I don't think this is the future of auditing. I don't think this is the future of writing software. I spend a lot of my time arguing with the build process of JavaScript. I don't hate JavaScript. I don't hate any language. Whatever you use to build your dreams is fine by me. But I want to point out that we write a lot of bad software over and over and over again. We write the same bad software. I have written implementations of LPAD, the thing that broke the whole JavaScript ecosystem that time. These are the things that are going to slow us down as an industry in a time where we cannot slow down. The people in this room are here because we believe in generally this decentralized dream that maybe we shouldn't turn our corporate world's leaders into gods and kings, right? And then maybe we should hold the keys ourselves, right? We should seize the keys of production. And I think that there is some urgency here in that the AI is coming, and the AI is going to decide largely, these algorithms that are being written now, they're largely going to decide the future of humanity. So we got one shot right now to put some rules in place. Think about Asimov's rules of robotics, right? These are the kinds of things that we need to put in place as invariants right now to protect our software and the stability of our software going forward, not just so that we can move more quickly as an industry and be more productive in our work, but so that we can prevent a future where we are being programmed by the programs that we write instead of programming them. So with that, I am going to wrap up, and I thank you very much for your time. I have a little bit of time for questions, but I would much prefer to take them in the hallway. So I'm just going to step down and invite you all to come forward and chat with me. I'm going to hang out here as long as you like up on the stage, and we can talk about all of it, okay? So thank you very much. I appreciate you coming down. Take care.